Good day, Mr. Stolle here. So today we are going to look at a difference of two squares, grade 10. It's part of factorization. So let's look here and see what we are required to know. So for example here, if we have got a squared minus b squared, we are saying these, both of them, a squared and b squared, are perfect squares. So we are going to add their square roots. So we add them and we subtract them. So your a squared can be anything, can be a number. So for example, if we have got 25 squared, so it's 25, sorry, minus x squared. In this case here, we are saying 25 have a root. What is the root of 25? So it's more like we are saying 5 squared minus x squared. Then what do? We add the root, square root of 25, which is 5. So 5 plus x, and also 5 minus x. That will be our final answer. Now, let's see here what we have. We have got x squared minus 16. And what we see that the square root of 16 here, we can just put it like this. So square root of 16 is 4. So in this case now, we are going to say it's going to be x. So it's more like we're saying x squared minus 4 squared. So here it's going to be x plus 4, x minus 4. That will be our final answer like that. So we add the roots and subtract the roots. That's what we're just saying. That's what we're doing here. Let's look at this. What is x squared minus 36? 36 have a square root. So you go to your calculator and punch square root of 36, and you see that it's 6. And now, once you know the square root of 36, it means that now it's going to be easy for you. You add the square roots, x plus 6, x minus 6. Then for this one here, we have got 9x squared minus 4. Now, 9 here, you have got a square root. What is the square root of 9? Is 3. So here, if you to punch here, root of 9 is equal to 3. So this means that it's more like we are saying 3 squared, x squared minus 2 squared, which is the root of root of 4. So then from there, we are saying this here, we are going to add the square roots and subtract the square roots. So 3x, in this case here, plus 2, 3x minus 2. That's what we get. Okay, let's look in the next slide, then see what we have here. What is 169 x squared minus 100? Remember what we said? We need to find the square root of 169, so, and also square root of 100. So this means that if we are to say 169, square root of 169 is 13. So it means that in this case here, we have got 13 squared, x squared minus 10 squared, root of 100 is 10. So adding the square roots and subtracting them, 13x plus 10, 13x minus 10. That will be our final answer. Then let's look at this again and see. But now, we are now having a different scenario now. We are now have x to the power of 8. How now do we get that? Okay, now understand something here. When we are doing the square root, so for example here, if we say square root of a is the same as a to the power of 1 over 2. So if I'm to have, let's say I'm to have a to the power of 4, then I'm looking for the square root. What I'm going to do is that you're going to say it's going to be a to the power of 4 over 2, which is equals to a squared. So square root of a4 is equal to a to the power of 2. So if we are to take it here with the space, if I'm to have, let's say I'm to have x to the power of 4 minus 1, Now, I know that the square root of a to the power of 4 is x squared. So it's going to be x squared minus 1, x squared minus plus 1. So you add and subtract. What about if I'm to have y to the power of 12, okay, minus x to the power of, let's say, 6. So what do you know here? You know that if you are to look for the square root of x, y to the power of 12, you say y to the power of 12 over 2 minus y to the power of what? Sorry, here, that will be equals to y to the power of 6. So the square root here, square root of y to the power of 12 is this, y to the power of 12 over 2. So you always have to divide whatever power that you have divided by 2 to get your square root. That will be y to the power of 6. So in this case here, it's going to be y to the power of 6 minus x to the power of 3, because we say 6 divided by 3. Then here we close the brackets, then you also add what we call y6 plus x3. That will be our answer. So coming to this now, we know that what is the root of 100 is 10. What is the root of x to the power of 8? X to the power of 8 divided by 2. We divide here by 2. We divide here by 2. What are we going to get? We're going to get 10x4 minus y3, then again 10x4 plus y3. That's what we get there. So that will be our answer now. So always when you're looking for the root, you actually have to divide by 2 the power that you have, the exponent that you are having, you divide it by 2. Then here, when you are looking for, you need to look for the root also of the value that you are given, the numerical value that you are given. Now, that means that here we're not going to have much of a problem here. Let's see what we're going to get here. So we're going to say n is going to be n4 minus. So remember, you can start with minus, you can start with plus. It's either way is correct. Okay. So as long as we have got a negative and a plus, and also a plus and negative, that's what we need to have. We need to add them and subtract them, or subtract them and add them. Still the same thing, nothing to worry about. Then here is going to be n4, root of 81 is 9. So n4 minus, minus 9, then n4 plus 9. That will be our final answer now, because we are saying root of 81 is 9, root of n8 is n4. We divide 8 by 2, then we get our answer. Okay, let's look at the next, our last slide and see. Now we have got 27a cubed minus 3ab squared. Now, in this case, now we are not going to apply difference of two squares directly. We are going to start by factorizing what we have here. How do we factorize here? We take out the highest common factor. We take out the highest common factor. So highest common factor for this one here will be equals to 3 goes into 27, also 3 goes into 3. What about a? We will take a, because a, we always have to take, when you remove the factor, we always have to take the one with the lowest order. So here a to the power of 1, which is just a. But in terms of b, we don't find b common here. It's not common, so we leave it like that. So we're going to take our 3a outside. Then what we left with? 3 into 27, we get 9. 3a into a cubed, we are going to get a squared. How did we get that? We subtract the powers here. We say 3 minus 1, then we get 2. That's what we do. Then here is going to be minus. We are left with only b squared here, because 3a into 3a is going to give us 1. So we're going to have b squared. We put it like this. Then from there now, we continue with our 3a there. But now what do we see now? We see that 9 is a perfect square, a squared is a perfect square, b squared is a perfect square. So what do? We're going to say root of 9 is 3, root of a squared is a, then it's going to have a plus b, root of b squared is b, then again we repeat the same thing, 3a minus b. Okay, still. So we are now having a plus b now squared minus c squared. How now do we solve that story? Okay, is it a big problem here? Look what we're having. We are now having a plus b. Take this a plus b as just, let's say, x or y. So in this case here, we are saying it's going to be a plus b minus a plus b minus c. Then again, a plus b plus c. That's what we're having here. A plus b minus c. Can we see what we're keeping constant here? We are keeping this as our root. This is our root. So it's a plus b minus c, a plus b plus c. And can you see the sign that we are changing here? We are changing the sign here, minus, and we also have a plus here. That's what we need to know. This is the same as, for example, if we are to say, let's say you can put it in this way and say, let a plus b be, let's say a plus b be, maybe let's say t. So we are going to have now, we're going to have t squared minus c squared. Then now, how do you solve t squared minus c squared? We say t plus c. This t, okay. Then also say t minus c. Then coming back, replacing a plus b, it's going to be a plus b plus c. Then a plus b minus c. That's what we have there. Okay, let's look at this again and see what we have. Now, with this one here, we're going to say, we start with, look at 2x plus y. We're going to say 2x plus y minus y, 2x plus y plus y. So can you see what we are looking at here? What we are focusing on this sign here. This is the sign that we will need to change. But 2x plus y remain the same. Just like what we have been doing here to keep a the same. We are keeping a there, we have a there. We are keeping b there, we have got the b there. That's what we're just doing here. We keep it as it is, 2x plus y, 2x plus y. Then here we can further simplify it and say, okay, y minus y is going to give us 0. So it's going to be 2x here. We're left with 2x here. Then what is y plus y? Is going to give us 2y. So it's going to be 2x plus 2y. Now, with this one here, we have got a 2 and a 2. It's common. We need to take out the 2 outside. So if we take the 2 outside, it's going to be 2 times 2 now. It's going to be 2. So we're bringing in the 2 from inside here. It's going to be 2 times 2x in a bracket. We have got, what is it? 2x now plus y. Then here, we're going to have 4x in a bracket, x plus y. That's what we're going to get as our final answer. Okay, we can also say, let 2x plus y be, let's say we can call it, let's call it a. Let it be a. So everything here, 2x plus y, let's call it a. So it's going to be a squared minus y squared. What do we do? It's going to be a plus y, a minus y. Then here, for this one here, what are we going to get? We're going to take back our 2x plus y. It's going to be 2x plus y plus y and 2x plus y minus y. Then in this case here, we're going to get a 0 there. Then here we're going to get 2x plus 2y. Then here times your 2x. Then here we factor out the 2. The 2 here is going to be multiplied with the 2, then it's going to give us 4x in bracket, x plus y. That's our final answer then. So here is the thing here. You're not supposed to represent all this. You take what is for you. You do what is easiest for you. But I think here, if for a start, you can start by substituting here, because it can be confusing also here. So here, you can start by what we call substituting and say, let 2x plus y be a. It's up to you guys. You see the method that is for you. Let's look at the last one here. With the last one here, what are we having? We are having 25a squared. 25 is a root. So we take the root, it's going to be what? It's going to be 5. Then what is the root of a squared? Is a. Very good. Then here, minus what the root of 4 is going to be 4. Then for this one here, because we are also looking at the root of this, what we call a minus b, it's going to be just a minus b. But since now we are having, let's put a big bracket here. Since we have a bracket here, we need to put it in the big bracket like that. Then you open another big bracket. We say 5a plus. Can you see the sign that we are changing? This is the sign that we are changing. Plus, because all these are perfect squares. So plus 4 in a bracket, a minus b. Now we need to take in the 4 now. We're going to say 5a plus, minus this one here. It's going to be minus, minus 4a. Then minus and minus is going to be plus 4b. We'll put it in bracket. We're going to say 5a plus 4 times a, 4a, 4 times negative b, negative 4b. Then here, we're going to say 5 minus 4a, we get a plus 4b. Because these are like terms, then 5a plus 4a is going to be 9a minus 4b. That becomes our final answer. Okay, so I hope you guys, you understand this and you've mastered how you are supposed to tackle this. Take your a plus b there, take it just as t, take it just as a small value, then you won't have a problem. Okay, thank you so much guys. Until next time, all the best.